Hello, everybody. Welcome to this new session. We're looking at today. We're looking at the next part of mission sizing, and we're basically going to be spending a little bit of time, but it's not a way to say that it's going to be long. It's a way actually to say it's not going to be long. But we're going to see how we define in IDMCIC the subsystems, the elements, and the team, so to speak. Well, in the different groups of the association, there is one specific for this satellite design, and there are already those who have joined. I don't know if any will be available to join us here tonight. I hope they will. But in any case, we're going to get it done. So if you're joining us, welcome. We are at the second spacecraft sizing session. We're going to spend time today on IDMCIC. It's very simple. I'm going to show you how, in a typical space mission, when we're looking at the design of the spacecraft, how we get to decide how to we get to define the subsystems, and how we get to define also the different members of the team that will work on this space mission. Now, for the subsystems that we're going to define today, we did a bit of a poll in the group of the association members who were interested in taking part in the hardware design and ultimately construction. And essentially it was, here are the subsystems, which would you like to work on? Some subsystems have been selected and others not yet, but I will define them, and during next week, the team will start getting their hands dirty on this particular satellite. I just need to make sure that all my screens are okay. Beautiful. So before I start, I give it again a few minutes, just in case somebody shows up as I shared the access to this live with the team. Just a bit of context again for a reminder, if this is the first time you're watching this series, if it is your very first video, if it's the first time you're attending one of these live videos, we are in the context of the NMD Association project. It's a nonprofit organization with the aim to provide pragmatic training to a maximum of Africans and beyond in spacecraft and space mission design and development, launch and operation. How do we do this? Well, we do it by actually designing and building and launching and operating a satellite. It's a big dare, it's a big, bold statement, but we're going to do it. One way or the other, we are going to do it. At this point, we are designing the satellite, and after that, we will be launching it and operating it. Well, building AIT and launching and operating. If you are interested in being a part of it, there is a number scrolling down the screen. Just send a WhatsApp to this number and we'll get you on board. All right. Okay, so we are going to get started. Good. So this is what the interface looks like. In the previous live session, what we did was to define the different subsystems that are going to make up this satellite. And I shared with you the decision to use the FOSSASat 1 and FOSSASat 1B templates that they graciously made available on their GitHub repository for anyone to download and use. Why this choice? We mentioned that we need this mission to be compatible with TinyJS. So given that TinyJS is basically goes hand in hand with the FOSSA satellites, it's natural that if you want a mission that is compatible with TinyJS, you would go with the design of the satellite that essentially started this whole TinyJS show. So that's why we picked this as a template to work with. Right, let's get down to business. As we saw last time, we have a few subsystems here that we are going to define in IDM CIC. I will start by adding the structure. There you go. Then I will add I'll add the power or EPS. I'll call it EPS. Let's just make it simple for anyone watching. I'll call it power. Yeah. Just to avoid an unnecessary abbreviation, although we're going to have one here because it's standard. It's onboard computer, OBC. There you go. And of course, this is a LoRa relay mission. So the star of the show is actually the communication. Communication subsystem. Right, so these are the different subsystems essentially that we'll have on this mission. We don't really have an attitude control. We could, because there is this passive ADCS that was implemented on the FOSSA satellites as described in the design. Well, let's go for it. It's a flexible thing, so let's add it, right? Let's add the attitude determination control system. Although it is passive, let's just add it. Beautiful. Now we have all the subsystems. Hello, Doc. Bienvenue. Welcome. Thank you for showing up. Hello. I'm going to add the elements now. These elements, to understand this, it's if you follow the training, the course that is available, again, like I said before, if you want to learn how to use this software, it's just become a member of the association, and it's all going to be there available free for you. If you want to understand what we are doing a bit better, to be sort of fluent, to follow along without struggling too much, all these courses are pre-recorded, made available. There's Introduction to Space Mission Design. It's pre-recorded. It's available. You can follow it free of charge. There is Introduction to Orbital Mechanics and Satellite Trajectories, not in the sense of heavy equations, but at least at the conceptual level, so that you can follow what we're doing and understand what happens when you learn how to use the software. And talking about software, IDM CIC, this one, the one we're using right now, you can learn how to use it. There is also a pre-recorded course with tutorials and everything available for free for all association members. We take it a little bit further. We have also a short course on space mission management. If management aspects are of interest to you, it's all available there free of charge. All you need to do is to join the NMD Association, become a member, and then you benefit from all these advantages, right? Be that as it may, if you just want to know what's going on, you want to join the WhatsApp groups, send a WhatsApp to the number that's scrolling over there, and we'll get you on board. Okay, so we have as elements, technically speaking, we can define here one element called the satellite. But for the sake of, I'll say for the sake of completeness, for the training purposes, because we are trying to get people to understand more what's going on. Although it's a pocket cube that like I said, has the size of a Rubik's cube, not bigger than this. We're going to define two elements. We could go further, but we're going to define typically the platform and the payload. Did I spell it correctly? Platform, yes. And I'm going to define the payload. Okay. Now, what is the platform? What is the payload? Also, these are easy things to find. The definition is in the Introduction to Space Mission Design. Essentially, the payload is the main instrument that does what the mission is about. Why are you sending the satellite? Which instrument goes to do what you want the satellite to do? The star of the show is the payload. And everything else that helps the payload to get its job done is the platform. So we have subsystems and we have elements. Right now, we need to do a bit of matching. So I'm going to match each subsystem to its corresponding element. So the structure will serve the platform. We could also, so I click on it and then it becomes green, and then the match is made. By the way, this is not your typical Excel. It's a whole different beast running behind. Again, the information of software is free to download. You can download this thing, learn it. It's not difficult. We could attribute also, we could also link the structure to the payload because, arguably the payload may have a different structure. But in this particular case, it is not necessary because it turns out that the payload is essentially one subsystem. So power is part of the platform. The onboard computer is part of the platform. The communication is the payload. That is the payload. Although we could argue that part of it is the platform, but the mission itself is about communicating, picking data from sensors on the ground and taking this data all the way to where it will be downloaded. Ideally, in fact, at the heart of it, it should be data that we will then broadcast for the entire TinyJS community to receive. So we will associate the communication subsystem with the payload. If we had defined a single element called the satellite, then we would not need to do this, but it's good to be complete. Then ADCS will be part of the platform, of course. It is going to be entirely passive. In fact, as we move forward, we will even decide whether we want to keep it or not, right? If we find that there may be too much of problems with the random tumble, If we want to at least, control to some extent, even passively, then yeah, we'll keep it. We'll see. We'll see. The design is there. We're going to use it to gauge a little bit how our mission will behave. Now, in IDM CIC, you don't do your typical Control S to save. You have this place called data exchange, and here we're going to commit. Again, what this means, you can easily find out in the training that is free to access as long as you are a member of the association. Just join, and then you can have access to all the training. Okay, so here we have defined the subsystems, we have defined the elements, right? What are we going to do next? We are going to attribute these subsystems to roles. The reason is that a file like this one is, in fact, this specific file in the context of concurrent design can be accessed by different people at the same time. But these different people are not doing the same thing. The person working on the structure will access this file. The person working on power will also access this file, but they will be doing different parts of the same satellite at the same time. And there's a guy who's going to be the systems engineer, or a lady, could be. And this systems engineer will then integrate the whole contributions of each subsystem and assemble it into the satellite we will see by the time we're done with this. Right, how do we then define this in IDM CIC? This is what I'm about to do. There is this little window here called system, and you go to users. Yes, the nice pop-up screen here. I'm going to try and make it bigger, although it's still not very visible. Can I zoom this? Did they plan for it to be zoomable? It doesn't seem so. What can we do here? Well, it seems to be a bit better this way. Not the best, but let's go for it. Essentially, we are defining users. We're defining users. Who are the users of this satellite model? There is the default user, which is system. We call it system, can be system engineer. Following some naming conventions, we're going to have managers of each subsystem. Why manager? Because each subsystem can be designed by a team, and this team has a leader, and we call the leader here a manager of a subsystem. Could be leader, could be team lead, really whatever you want, as long as you understand this is the person in charge of the subsystem. It doesn't mean they're working on it alone. Okay, we're going to create a new user. It just says user 2. And we will now define them according to the subsystems. So I'm going to create a manager for the structure. What could I call this person? I could say structure manager, but let's just say for argument, I call this person mechanical engineer. Why? Because I'm trying to use a vocabulary that will make you understand that to build a satellite, you are using specialties that already exist for the most part. You will see why. So I just created the mechanical engineer. Let's see if you can make this. No. Right. So there you go. That's the mechanical engineer. Let me create another one. So the mechanical engineer for the structure, no? Now let me create another one for the power. Okay. Now, for power, we know that there are specialties. People go to university and specialize in power systems. So this is a power systems engineer, heavy power, light power, whatever, really. So let's a heavy current, light current, or whichever the case. But this is a power systems engineer. So I put here power systems engineer. If I say power engineer, let's just say power engineer, because the nomenclature can vary from one university to the other. Let's not be difficult. Onboard computer. Yeah, it seems a bit, but who can handle an onboard computer? Well, there is an embedded systems engineer. I'm sure you know about embedded systems because many people study it. Les systèmes embarqués, ceux qui font les systèmes embarqués, they can actually work on flight software and this kind of stuff. So, embedded systems engineer. There you go. Then we look at communications. There is really no news there. You have now, okay, it's true, it can be ambiguous because some people may think that a telecom engineer and a comms engineer is the same thing. There are big differences, right? To be careful. So here I'm going to look at the communications engineer, okay, or electrical communications engineer, or what one would call a comms engineer. In fact, I'm going to use the name that is found a lot in academics. I'll put 2 M's because I'm that guy. Yeah, I'm that guy. Engineer, comms engineer with the apostrophe, because I decided I'm going to be that guy. And then the ADCS, attitude, determination, and control system. Well, there is also this specialty that is called control systems engineer. And I know that many of you listening may be, or maybe not, or maybe you know somebody who is into control systems. And the person who manages the attitude of a satellite has a background of control systems, right? So if you're doing that, then yeah, you can be part of a space mission working on control. So controls, controls systems. All right. Yes. Your ADCS being passive, make sure it is thermally stable. To avoid drifting out of reach. This is very true. And it is thank you for that, Prof. It is true. In fact, I was even hesitant as to whether we're going to put the actual passive ADCS there. Like I said, we sort of put it in brackets. The only reason it is there right now is because we're using the FOSSA template, and it was there, but we're going to do our own analysis and find out for ourselves if it's a good idea to leave it there or not. Because indeed, the whole thing being passive, we are not planning to have any active thermal control. It would be too bulky for Pocket Cube, this side. So thank you for that comment. Systems engineer, looking at controls. Okay, there you go. So I think we have added the different subsystems. We've added the users. Now let us give them access to what they will see, or let's define what they will be able to access when they connect to this model, to this satellite model. In a concurrent design environment, different engineers have access to the same model, but they don't have access to the entire satellite. Each engineer has access to the subsystem that has been allocated to them. So let us do this allocation. Whoever in this particular ecosystem will be the mechanical engineer. Let's start there. The mechanical engineer, we say that we want this person to access the structure, right? And I'm going to leave it at that for now, because we haven't gone down to what scenario files are, etc., etc. But you will notice that you have a separation between the platform and the payload, right? So it's important. Let me expand this here and expand this one. So everything that is allocated only to the platform, you'll see it's just the platform. But configuration, how the satellite is configured, has to do with both the platform and the payload. The mass, how heavy will the satellite be, has to do with both. The power, both. And of course, thermal, like the elder just mentioned, is both, okay? The scenario files, we will discuss them a little bit later, but they are of interest. So we have said that the mechanical engineer is going to deal with structure. That's what we said. The power engineer, we say he's going to look after power, but notice that structure is no longer available to anyone else because we have now allocated it to the mechanical engineer. So we do the same with power. The embedded systems engineer, we give to him the onboard computer. The comms engineer, we give to, I have specific people in mind that I think are going to be very irritated by the way I wrote comms here. And I'm happy about it because I'm a nerd like that sometimes. Communications subsystems, and the controls guy, we give to him ADCS. And we now go to the systems engineer. And we decide that the systems engineer will look at system configuration. He will be the one to first do the overall analysis of the system mass, power mass, and scenarios. We'll get to that later, but I already give this role to the systems engineer. Now, we could do something else. We could decide that we want to do a spacecraft configuration that has to do, that we would allocate to the mechanical engineer. Typically, when it comes to configuration, it would be this guy who is in charge of AIT, as assembly, integration, and test. But for the purposes of what we're doing here, we will start off by putting it on the shoulders of the systems engineer. But note that he, on the configuration side, for configuration mass, he will have to be working with the mechanical engineer. Power, he will have to be working with the power systems engineer. And of course, thermal, but okay, let's just add it for completeness. Although we won't really use it, we're not going to be doing it. I'll leave it for now, and then if we need, we come back to it. So we have attributed roles. We have attributed roles. We have decided who can do what when they access this model, okay? So this is a very important stage. I'm going to close this. It's going to take some time to reload, and now it has integrated this new data. As you can see, there are a few things. I am right now here as in the role of systems engineer, and now it has given to me the configuration tab. It has given to me the mass budget tab. It has given to me the power budget at the element level and the power budget at systems level. All of these are going to become populated as we progress, right? All right, I see a nice comment here. Life for this tiny satellite will cost few grams. Yes, it will be a good thing to perform some thermal analysis in the current design facility, at least to find out whether it is needed or not. Too cold or too hot may kill your satellite its beginning of life. This is true. This is true, especially around orbit design. The intuition of just saying, okay, we're going to have a shot at ISS is a bit too gratuitous, and you need to know what you're doing. You are right. Let's do it for completeness sake. Because the majority of our audience will not know. It's too quick to say because you've done it a few times. It is true. Thank you for that reminder. I am going to separate and create. Yes, because you have different tools specific for thermal analysis. I'm going to separate and create a thermal, the rare, this is like unicorn tears. Les thermiciens, like we like to call them by their names as if it were something, something of a tease. It had thermal control engineer. There's a C. Again, there are different names. I'm going to go with this one. And to him, I'm going to give this task. Yeah. Good. So that at least by the time we're done with it, the whole story is clear. The reason why we go for it or not, because even in the design, you have the dissipation that you take into account, which you need to account for at the end when you're justifying your decisions. And also according to what your orbit ends up looking like, you may actually. Thank you for that. So today it was okay. First, let's save this work. Let us save this work. Put it on commit. Say yes, and it is saved. This file, like I said, I'm going to share it with the association members so that you can have it. When you do the course, the small training about how to use IDMC-IC, you have to complete already one tutorial to build the drone, and then you complete another tutorial. And it is a very Ruth is joining us. How do I get to say device not connected? Ruth, I hope you don't have some internet issues. It would really be fantastic to have you over here, but it seems your connection is not the best. Let's see. You need to connect the mic before you. Oh, you're having a microphone issue. So you need to connect your microphone before you can join the stream. Please check if your mic is okay. Otherwise, it's going to be difficult to have you on board. So, like I said, during the training, you have mainly two tutorials. The first is a classic tutorial made available by CNES, which is the French space agency, to just get yourself able to use different functionalities, and they use a drone tutorial for it. It's a beautiful tutorial. Then what we did in partnership with the CSUM is we made a model of the first African CubeSat, TepisoSat 1. We went on the basis of the work done by Dr. Flavien Mingo, but back then he was a master's student, and that was his master's work. And we rebuilt his design of the first CubeSat as done in his master's work. That was not the final version that ended up flying, but that was basically the ground on which the rest of it stood. And we built it, and it is a tutorial that when you do this training, you will also get to complete. By the time you've completed both tutorials, your hands are dirty enough to understand how this whole thing works out. It's such a pity. It would have been great if Ruth could come on board. I don't know if, Prof, do you want to come on board, say something? Let me try and get you, get an invitation through to you if you have a, if you can. That would be great. Let's try that. Let's try that. Okay, I just sent you a link. I just sent you a link. If you can, give it a few minutes, just see if it works out. If you can, it would be fantastic. Otherwise, well, maybe next week when we do the next one, if you're available, that would be great. But essentially, we are basically at the end of what I wanted to cover today. The intention is not for these lives to be long and kilometric, but to be methodical and practical. And it's very important also to note that what I'm doing right here is what those who use IDM-CIC, and there are many of them who have used this to design spacecrafts that are in orbit today, many of them including myself. And this is what we use. This is what we use. So, but it's a pity. It seems Ruth is having some microphone issues. Thank you so much, Ruth, for trying to join us. We'll see. We'll try to fix that so that next time you can come on board and you know, we do better. Okay, this is what I wanted to share with you today. We'll take it from here. Ideally, not me. My desire is for the rest of the team, and just to share with you, my desire is for the rest of the team to get to dive on it. We already have, like I mentioned before, from Senegal, from Ethiopia, from Cameroon, who are right now ready to go. I think even there is from Chad. I think it is Chad, but I will confirm. Yeah. If you are, I mean, the more the more the merrier, right? Thanks, Prof, for the kind words. Thank you. It's very encouraging. Let me share. I think I can show this comment because I'm grateful for it, and it comes from our elder who used to work at the European Space Agency, and he's now retired, and he's an elder. He's a guide to us youngsters trying to push the African space agenda forward. No, so we're really grateful to have minds like this, sort of mentoring us, helping us to move forward. Thank you very much. Okay, everybody, this is the end of my story for today. I'm going to share this file as updated on the shared drive that is available to all association members. In fact, on your member portal, once you log in onto the association website, you go to your member portal, There is now a space to download files, and I'm going to make all of these available there, right? Okay. Thank you, Ruth. Thank you very much for your kind words. Really appreciate them. Hopefully, it is a bigger party next time. And as we move forward, I would really love this to, host many people who jump in and exchange views, and we discuss this satellite in real time. It's fun. It should be quite the party. Okay. Keep well, everybody. Thank you for your attention and your time. I will see you next week, same place, same time, for part 3 of the spacecraft sizing session. Bye-bye.